Finally, let us take a look of the vector-based implementation for the stack. To talk about the vector implementation, you need to understand the standard library. As you have seen in your program, you call a library IOStream all the time in the beginning of your program, so that all of the functions provided in the IOStream are available for you. Therefore, you are able to use cin, cout, endl, those kind of things. It is the same thing for us to use the vector. So a vector contains the contiguous elements stored as a dynamic array. This dynamic is the key difference between the vector versus array. In order to use the vector, in the beginning of your program, you need to include the vector library so that you will be able to use all the functionalities provided by vector. To include the vector, just like you did in the beginning of the program, use a #, include IOStream, and then use a #, include vector, so that all of the programs available for the vector will be included in your program. So once you have done that, there's actually a lot of different functions that you will be able to use in the vector. If you did not include a vector, you will not be able to use all of these functions. This is just a short list of the functions available for the vector. Of course, we are not going to use all of these. I will only introduce you the one that's related to the stack. The basic functions, as we discussed earlier, constructor, empty function, push, top, and pop, are the functions that we are able to implement in the stack. And of course, display requires a loop to walk through all the items inside of the stack. Corresponding to the vector implementation, surprisingly, it is super easy. Every single function has only one function to call to, and you will be able to implement the corresponding stack functions. Constructor, let's start with the constructor. This is how we will be able to call a vector. To construct a vector space, you simply type in vector using this special bracket and define your data type. So if your data type is integer, put integer. If your data type is float, put float. If your data type is char, put the characters over there. Then you need to provide a name for your vector. So this name can be any variable that you want it to be. Put a semicolon indicating that you have finished the vector declaration. So that is simply your vector constructor. Then, if we look into the empty function, to test whether or not the vector is empty, you use L.size. This is something we have been used since the beginning of the semester, so that you probably have seen this many times. If the size equal to 0, then it is empty. To do the push, because we are adding the things in the last location, so basically, we use L.pushback. It's basically the same thing that you have. Put a value, and you don't need an address location because there's only one place you are able to push, which is the end of the vector. So that once you push it, you will add a value into that. And you will see when you define the vector, you do not specify the space because the space can be dynamically generated. If you do a push, you add one more item. If you do 2 pushes, then you have 2 items over there. Top is simply output L.back that will give you the very last element that you have pushed into it, and then that's the top function. To do pop, it's again the same thing. L.popback, and then put a parenthesis without any parameter because there is only one place you are able to pop things out, which is the last location. To do display, you simply write a for loop from I equal to 0 until I less than L.size because you don't know how many elements over there. L.size will tell you that, and you will be able to go through every single location and then output the values that you have. Therefore, if we take a look of a very simple example that will fully runnable on a vector implementation, in the beginning, include IOStream, include vector. Like I said, this is the most important thing to run a vector program. Then using the namespace std, and you will be able to walk into your main function. Inside of the main function, as we see, we need to define a vector so that we have a constructor input over here. Once we do push 1, push back 1, push back 2, push back 3, that's equal to push 1, push 2, and push 3 in our stack implementation. When we do l.pop back, that means we do a pop operation so that we will take things away. The traverse or the display function is given in here. You can see that int when I equal to l.size minus 1, and then as long as I is greater or equal to 0, I minus minus. Obviously, for the stack implementation to output everything, we use a reverse order, starting printing all the things from the top until the bottom of it. So you see that once we are able to use this loop, notice that in your cout, we use L of bracket using an I in space over here. This is exactly the functionalities that you can access in your array. So you see that this is something we already know in the array implementation. For vector, it's something very similar to array. The thing is that it will use a dynamic method to create a space for the vector. It usually creates a contiguous space for a small amount of it, and then use the linked list concept, linking from one chunk to the other chunk, so that when needed, it will be able to create additional space. And all of this is hidden inside of operating system, so operating system will know which part belongs to which part, and then they will be able to connect all together. Of course, it will take additional time to implement vector compared with the array. So array will have a better performance. However, vector has more flexibility. The assignments I want to give you guys is this one. Based on the vector implementation, I want you guys to have some experiences in it. So this is something very simple. Don't overcomplicate it. What I want you to do is write a C++ program similar to the one that we see. So basically, you would have the first 3 lines exactly the same, have the main function are the same, create a vector, whatever name that you want it to be. What I want you to do is that I want you to use vector to push 10, push 3, push 7, push 8, push 4, and I want you to run the display function to show me what is happening over here. So what's the items in your stack, and then pop an item, show me what's the stack looks like after you pop, and then pop again, and then show me the stack. So basically, this program would probably take you only 1 minute to run, but I want you guys to have some experiences in the vector so that we will be able to use the vectors in our rest of the semester. Of course, you feel free to play with it. There's many other functions provided by the vector, and I want you guys to have some fun with the vector implementation. Once you finish that, simply take a screenshot and then submit the screenshot through the Blackboard, and I will be able to count you as your attendance. In the beginning of this topic, I mentioned that you actually use stack in your mind long time ago. Probably in the CS1, in the middle of the CS1, you already have this concept. You just don't know that is stack. So let's talk about this. Whenever a function, everybody write a function. Besides the main function, if you create another function and inside of the main function calls that function, have you ever think about how does that work? Let's take a look at this. Whenever a function begins the execution, including the main function, an activation record is created to store all related information. Those information including values of its parameters, contents of register, the function's return value, local variables, and more importantly, address. When a main function is called, it's stored in somewhere in the memory. So there's actually an address that you will need to go to and then execute the code. If some other functions are called, you also need to go to that location. Once that part is done, you need to have a return address. So the address has something very important handled by the operating system. Let's take a look of this example. You probably understand that in our main function, and you probably wrote some functions like this before. There's a main function a equal to 3. So think about this. That requires a place to store that a equal to 3. And then function 1 has been called. So think about this. When the program is running the first line, on stored a equal to 3 goes to the second line, sees F1, you need to be interrupt and then goes to function 1. In function 1, you need to take the parameter, go see out something that's stored in function 2. And therefore, you need to be interrupt again, goes to F2, and then sees that there's another F3, you will go to F3. Think about this. This F3 is the last function call. So when this is done, this will be the first one that returns to function 2 and then returns to function 1 and returns to the main function. This is the stack concept. Like I said, since you already wrote some programs like this before, you have this in your mind. Function may call another functions and thus interrupt their own execution. Some data structure must be used to store these activation records so they can be recovered and the system can reset when a function resumes execution. This is the fact that the last function interrupt is the first one reactivated, which is a last in first out concept. So a stack is a private structure, and since it is manipulated during the execution, we actually give it a name called the runtime stack. So you can see that every time whenever a function is called, you will create a runtime stack. Inside of that, you will store all related information, parameters, function values, local variables, arrays, vectors, and you also need to have a return address to work with so that you will know where to go back to. And finally, everything when things are going on top of each other, a runtime stack will be formed, and then that's actually what's happening in back of the operating system. So you actually need to appreciate that operating system is actually done a lot of different things for us. Hide the details, but we are actually able to write the program in our mind and perform whatever we want it to be. This kind of runtime stack, we will have a much in-depth discussion when we reaches the recursion status. So when we comes to recursion, we will see this kind of things in a much more detailed way so that you can have ideas of what is the runtime stack going to really execute in action.